right, so let's get started. So thanks for coming to this talk. The name of this thing is called IRFC. So what IRFC stands for is, well, it's a design pattern for immutable requests for change. Feels like end of a long series of sessions. Hopefully you guys have liked the conference so far. So it's like, this one should be hopefully quick and easy. It's a relatively simple idea, simple design pattern. As a design pattern, it's just another tool. Some rough guidelines to put into your tool belt, have in your design approaches. And what it focuses on is more about next generation business applications. My name is Steve Yen. I'm one of the co-founders here, so I've been thinking about distributed systems and scalability and databases for quite a while. The idea here is you have all these great technologies, like Couchbase technologies. How do you build a next generation business application on top of this stuff? Right? How do you weave it all together, right? Sort of an interesting question. One way to think about it is actually you start looking back at old school approaches for inspiration. And by old school, I don't mean relational databases. I don't mean RDBMS, entity relational, fourth normal form kind of stuff. I mean something slightly older than I mean old style paper document forms. This is the real paper documents that some of you might remember, where you actually had to write really hard, make sure you got all three copies, and you would send the yellow version to accounting, and shipping would get the pink version. I can't be the only one who remembers this stuff, right? This is like it was like magic chemistry, right? It's like chemistry for better living. It's like somehow your fingers would not get dirty. Pretty cool. One other downside about this stuff, though, is you couldn't use an eraser. If you tried to erase on this stuff, you'd just get a mess. It would not work. It was bad news. And another part of this is you couldn't actually take your white copy and change it a little bit, add a few zeros here and there, and before you know it, A, people are laughing at you, and B, you're fired, right? Because that's not how it works. You actually have to take another form, peel that out, write hard for all the three copies, and route that through the organization, follow up, and staple it back onto your original white copy, et cetera. So there's some received wisdom with this way of doing things, right? When you have these documents, by definition, they're denormalized. You got copies of this stuff all over it. And they're replicatable, and they're routable, and they're also immutable, which is an interesting thing. So circa 2015, we have all these great technologies. It's like, oh my God, it's 2015 already. What happened? We have document databases. We have like this NoSQL revolution, and like this way of doing things, and things are like flexible schema, and no schema, like things that actually can support this kind of pattern of working. And at least in Couchbase technologies, especially with like the mobile and Couchbase sync gateway, there are these really powerful, really cool sync functions and channel functions that allow you to actually have really powerful replication and routing. So these are things like, the analogy I like to say is like if you all know MapReduce functions are, what MapReduce functions are for like batch processing, these sync functions and channel functions are for similar to replication and routing, right? Very powerful stuff. If you've attended some of the other sessions or seen some of the other technical documentation around this, it's actually quite interesting. And literally or figuratively, I'm not sure which was the right word, immutability is the bottom line. This is, if there's only one takeaway I could have you all have in your head about how do I think about designing my next generation business application, it's this immutability, which is an interesting way of thinking about things. And none of this is necessarily new. Like there's a gentleman, his name is Pat Helland. He writes really interesting content and like clever titles like immutability changes everything. Accountants don't use erasers. Some of the patterns that I'll be talking about are somewhat similar to this design approach called CQRS. It was mentioned in one of the earlier keynotes yesterday. So this is a little bit like CQRS on steroids, on distributed steroids. Maybe that's like a little bit appropriate since we're actually at a professional sporting stadiums. I wish I could get the live stream camera guy to just pan toward the right to see, so you could see the beautiful view out there, but let's keep on going. Here's another old school system of record, right? You got your web browser, you got your web app server, you got your database. Hopefully it's a nice consistent database, like it's probably, for example, Couchbase. You're going to be storing JSON documents in this thing. For those of you in the back who can't read this, this is actually product 45. Version 1, it's a t-shirt, size is large, it's $10. And the thing is, you can get your browser, it can make a GET request against this thing, get its own copy. That's denoted up here by that little document in pink with the version number 1 in it. And the nice thing about this is like now that it has its own copy of the JSON, it can render this thing to the user's eyeballs however it wants. You know, you got your single page application, you got your AngularJS, Ember.js, React.js, pick your poison.js. As they're clicking around, no problem. You don't have to make any more requests to the server. But of course, next, the user wants to make some updates. They want to like fiddle around with the drop downs. They want to do something. And then they're going to hit the save or the submit button. And so you're going to get another JSON request coming into your server, which is nice. You know, I want to change the product price from $10 to $15. And now the server side can do whatever it wants with that, including checking business logic, making sure the price is a number, it's not a negative number, it's all good. And you can do things like, for example, update the document in place. You get a nice consistent database where you can do that. Or you can create a new version, a copy of the document. It's up to you. The design pattern doesn't really, you and your team have to figure out the trade-offs on that yourself. And you're going to get a response. You're going to say, OK, it's HTTP 200. It's all good. And the browser is going to get its own version of the updated business document, which it can render back up to the user. But what might happen? Like a concurrent client might appear. This is, again, no problem. Another user might be pointing her own web browser at the server and sending in a change request JSON document, trying to change the price down to $8. Unbeknownst to her, the price was changed out from underneath of her. Going to get a conflict. Easy. Everybody knows this, right? This is all familiar territory. But what if? What if we actually, well, this JSON here that we were looking at, this like change request JSON document, it's actually this ephemeral thing. You know, we don't hold on to it, right? It's just this like thing that's in memory, part of the request, gone. What if we actually held on to it, right? In order to hold on to it, you know, you might have to assign an ID to this thing. And why would you want to do such a thing, right? Well, on the one hand, what if the server gets really slow? It gets so slow that it actually looks like it's down or something, right? So that's not good. This business logic that's on your server side is no longer available to you. You can't check validation stuff and model view controller, you know, foobar, whatever you need to do. Well, then you might be lucky. Maybe you're running on your server side with some fancy, you know, Node.js, and you can have a some subset of your JavaScript that's running on your server side, available on your client side. Maybe you're using some older school Java and client-side GWT or something like that. Some subset of business logic can run on both sides. So what happens when you get a change request, you can actually run that client-side validation logic, right? You can get these provisional model updates, right? They're not the source of truth yet, but they're provisional. And what you can do is you can start updating the documents that you have on the client side. You know, you can update your copies of those documents. And that might be OK if the documents are relatively simple and you can keep track of what things are going on. Or there might be like CDRT kind of like patterns that you can apply that keep things sane. But on the other hand, in order to not get yourself into a crazy situation, it's actually sometimes a lot easier to just update another version, another completely different document, which we're showing here in dark red. And this is a provisional document, a provisional business document. It's not down on the source of truth yet, right? It hasn't hit the server side, right? Server side's down at this point. So what can happen here is like as the user's clicking along and making changes in their application, in their client, you're going to get a stack of change requests, and you can keep on applying it through this loop and update your provisional business document. And you could display it appropriately to the user, saying, you know, those changes that you made on the prices, they're still provisional. You could, put UI affordances there so you're not lying to the user. So you got a stack of change requests. Eventually, yay, good news, the server's going to come back online. And that means your source of truth, your system of record is good. It's returned. And now the clients can now start connecting back up to the server, right? Now, it might do that in like one AJAX request and send like this whole huge bolus of change requests all in one shot. Or it might do it like onesies at a time, right? It's up to you, you and your team. There might be different trade-offs you need to make there. But either way, for example, in the second case, the server doesn't really detect any difference. It's just like peeling through incoming REST requests one at a time. And it can do its things like check for concurrent changes, check all the business rules. It can call out the third-party systems. Like there might have backend systems that credit checks and I don't know, concurrent currency exchange rates or stuff like that, and make sure everything's cool. And then update server-side business documents appropriately. Eventually, it's going to, for each change request that's been coming in, it's going to create these things we're going to call change responses, just more JSON documents, right? So each change request is going to get paired up with a change response document, and those change responses can make their way back as results or responses back up to the clients, and the clients can pick up their own new versions of the latest and greatest business documents, and it's as simple as that, right? The server that was offline, you've been staging everything on the client side, having these change requests stacked up. Eventually, they get all flushed down. But what about mobile, right? So this is the picture we've been looking at before with the classic, web browser, web server. Let's push that off a little bit, make some more real estate on this diagram. And you can deploy things like Couchbase Sync Gateway now, right? So now your web app server, your server-side business logic is now a client of Sync Gateway, and you can have one or more Couchbase mobile clients appearing and connecting up the Sync Gateway. And what's going on in your Couchbase mobile device is it's synchronizing with the Sync Gateway and getting its own copy of those business documents, and it can render that to your users. And when mobile being what it is, you're going to eventually lose signal. And same pattern applies. Servers looks like it's down, and you can get all these change requests stacked up. Run your client-side business logic or your subset of the business logic that is available to you, and get these provisional documents that you can now render appropriately up to the user. Simple idea. So eventually the signal is going to come back. You're going to synchronize up to the server. All those change requests are going to get flushed onto the server side. Change response documents are going to come back and get synchronized back up to your client. And then next versions of business documents are going to come into your client, and you can render them appropriately. Some of those change requests and change responses, they might be accepts, and yeah, cool, we accepted your request and processed it, and here's the result. Or they might be rejections, right? Say, hey, while you weren't looking, somebody changed this document, some business rule isn't met. Now, you and your team can start thinking about clever things that you could do, with, there are certain business operations that actually, it doesn't matter who is winning the race, right? You could say, oh, these are just increments on some certain numbers. You can apply clever things like that at that time. One thing that you might want to do at this point too is, at least for the mobile side of it, some teams that I've seen have actually updated their green change request documents instead of just creating a brand new yellow document, a brand new change response document. That will work fine, especially if your change requests are actually relatively small. If your change requests are actually rather large, you might want to think about this other pattern of actually having separate yellow change response documents. So the thing is now, these requests, these green things and yellow things, these change requests and change response, they're now actual, honest to God, real documents. They're routed JSON documents in the world of Couchbase Sync Gateway and Couchbase Mobile. And that's how we take care of mobile, right? Simple pattern, not too hard to follow. And one other interesting thing is now Sync Gateway is now actually, you can view this thing as kind of like an interesting message queue, a distributed message queue system, but it has this really advanced sync functions that allow you to control all the routing and replication. You could say, oh yeah, these documents, they're only meant for the West Coast guys and the West Coast sales team and West Coast region. These other documents the executives get to see, whatever it is that apply to your business. It's a really flexible a platform and feature set that lets you to do a lot of cool things. And it also works for more advanced mobile topologies. For example, you might have a retail store where you want to give all your retail associates a little handheld device that, like at the Apple store. And what they're doing is they're typing in stuff on while they're talking to customers, but they're actually synchronizing with a little a Couchbase mobile or Couchbase Sync Gateway that's running in the back office of the mobile, of the retail site. So if that retail store loses connectivity with headquarters, no problem. That store can keep on trucking along. So the star topologies or hub and spoke or even peer-to-peer also work for this pattern too, which is a nice thing. This is how things like you heard at the keynote, the locomotive kind of examples where you actually have interesting synchronization topologies. The way that would work is in your device you would actually have your business document and you're stacking up a bunch of change requests that you haven't synced back because you haven't talked to headquarters in a while. But meanwhile, you do synchronize with a colleague's device. And so change requests from your colleagues are going to be coming into your device and vice versa. Your change requests are going to be swapped out with your peer's device. And eventually you're going to be building up all these change requests. Now you want to carefully record and remember the provenance of these change requests. You say, oh, these certain change requests came from my device, and with device ID information, that's easy to do. These other change requests came from my peers or my colleagues out in the field. Eventually, one of you is going to make it back get connectivity, make it back into talking to the main servers in the center. And, oh, sorry, before you actually get there, of course, you're going to run that client-side business logic, get your provisional business documents, you can display the thing up to the user appropriately. But eventually, you're going to synchronize back up to the center. All those change requests are going to eventually get onto the server side. It's going to paw through that stuff and get your change responses. And those change responses are then going to get synchronized back out. And all good, including you're going to get the next versions of your business documents synchronized back out to your devices too. And that's how you actually end up with like dealing with interesting topologies like peer-to-peer synchronization of your next-gen business applications. So we've sort of talked about this like zoo of different colored documents. Let's just give an overview of how this actually works more in tabular form. So we had these pink business documents, we had these green change requests, yellow change responses, and these dark red provisional business documents. So which one of these are immutable, which one of these are replicatable, which one of these are routable? The business documents, well, they're not quite immutable, they're versioned, right? But since there's a clear system of record on the server side, you have a very clear version history, and it's a clean line of history. But the versions, once you make a version, once the server side or the system of record makes a version, it's immutable. And at that point, it's easy to replicate and route. These change requests and change response, they are immutable, and so they're easy to replicate and route. These dark red provisional business documents, they are mutable, but they're not supposed to come outside of your device. There's supposed to be these client-side only things that you don't actually route around, right? In terms of like who creates these things, who updates these things, well, the system of record, SOR, system of record, is the clear owner of responsibility. That's a guy that's going to be creating the business documents and updating the business documents. So the center server-side systems. The change requests come from the clients. And they're not going to get updated. They're immutable, right? The change responses, that's the responsibility of the server side, the system of record. And again, they're not updatable. They're immutable. These provisional business documents, that's all client-side stuff only. They're not supposed to leak outside of the client, not supposed to leak outside of the device. In terms of who can delete these things, it's pretty straightforward. For the business documents, the main deleter is the system of record. For the change requests and the change responses, it's actually the original requester that should be the one deleting these things, but only after it gets a paired up change response, right? And vice versa. You can delete the change response once it sees a paired up change request. And as an extra thing, your team will probably want to think about like, oh, well, there might be cases where that guy, he went out into the field and he hasn't synchronized back for like the last month. I still need to have some like timeout expiration thing where I'm going to do a server side, delete and clean up of this. Of these change requests and change responses. This pattern, this IRFC pattern, covers a lot of different interesting business scenarios. All the old school business documents that we used to know and love, from like all those paper documents, product items and customer records and vendor records and invoices and sales orders, they all fit into this kind of pattern. So it's an interesting, pretty general pattern. You could think of like item transfers if I need to move an item or counts from one location to another, or count transfers, or I need to move for a game, maybe like the Black Sword of Destiny from your player account to my player account. You can do all that kind of modeling using this pattern. Even these second level kind of documents, you might not necessarily think of them as documents, but these dashboards or leaderboards or like kind of report that are kind of like generated from primary source documents. After the server side generates a report and it gets like synchronized out to the field, as I'm out there on my mobile device and I'm mucking around and making provisional changes on business documents, I might want to see the counts and other things on these leaderboards also get provisional aggregate updates. And that's an interesting pattern that is now possible to think about, and how you want to see what kind of change needs to happen there and how does that actually flow through the system. What this might not work as well for, however, is things like these things like a million votes or likes or pokes, and you need to think about like techniques from Matthew Revel's talk about how do you actually take these large documents and like subdivide them, and should I embed, should I refer information based on like brand new documents, or should I just like clump them into one giant document? All good stuff. So we've just scratched the surface. There's lots of stuff and trade-offs and all interesting things to think about with this pattern. But usually when somebody says this kind of stuff, that means it's nearing the end of the talk. It's time to wrap up. Just wanted to present this high-level thought of like IRFC. This is a way, something to have in your back pocket. It's not the only pattern. There are things like CRDTs, and you want to probably look at CQRS. Interesting patterns that you can get to in order to get to having your team build out your next generation business applications that are mobilized and occasionally disconnected. So a quick recap, IRFC, immutable request for change. It's this old school inspired design pattern that deals with immutable, replicatable, routable document data. It's mobile friendly, deals with multiple topologies, meant for your next generation business applications, and it has pretty colors. And I think it has actually a hashtag too, so that's all I had. Open for questions. I'll certainly be hanging around too at the end of this if there are any more. Thanks.